Okay, so I'm talking about that review packet for the final, and today we are going to start with number 1. It's log base 4 of 4. And some kids ask, can you use a calculator? Yeah, you could. So if you knew how to type this in, by the way, how would you type that in the calculator? Log 4 over log 4. And just to make it more clear, let's say this had been a 10. You'd put in log 4, the one on top, the one that's up here, over log 10, in case you had forgotten how to put those in. All right, but back to this one. It's log base 4 of 4. Don't even need a calculator, because I know if these two are the same, then the answer is whatever the exponent is on that one. And the exponent there is a 1, and therefore the answer is 1. Okay, so does that help you for the next one? Look at problem 2. B, sorry. This is 1A technically, and then what I'm talking about is 1B, and that's log base 3 of 81. Well, it's different. What do you mean, server? Well, because the 81 could be written as 3 to the something. Do you know what it is? Is it 3 to the first? No, that's 3. 3 to the second? 9. 3 to the third? 27. 3 to the fourth? Yeah, 3 to the fourth. So if I can rewrite that as 3 to the fourth, do you get how it's basically the same kind of a question? If these two are the same, then what's the answer? The exponent. And what is the exponent? 4. So the answer is 4. All right. Now, there's a few other rules that I just generally want to talk to you about. Do you remember that this is not a specific problem? There's one like it on here, but if I had 12 log base 12 of 20, do you get that the answer would be 20? Do you remember if these two are the same, then the answer is that one? That's one of those little rules too. Okay, that's going to come in handy on letter E as an elephant. You might say, but wait a minute, there's no base. Do you remember that if it's log of 5, that really does have a base? What base does it have? 10. Do you remember if it's ln, what base do those kind have? Base E. ln, if it was ln of 5, that means log base E of 5. Okay? So if you see ln, think log base E. All right, next little thing. Do you remember that if I have log 5 negative 2, that I'm not allowed to have certain numbers in these spots? Do you remember I can't have negatives? So what would the answer to that question be? Undefined. If you tried it with a calculator, your calculator would say it's out of the domain or whatever, because you're not allowed to have negatives here or here. You also can't have 0 in either spot, and there's one more restriction. This one right here cannot be what? Can't be a 1. You can never have a problem like log base 1 of something. Because let me show you why. Let's say it was this. Log base 1 of 8. What that means is, I don't know what the answer is, but I can put an x here. And now listen, this is one of the most fundamental things about logs that you got to remember. That's a log. Can you rewrite it as an exponential? Yes, you can. You could put it as this to the this equals that. You remember this? 1 to the x equals 8. Now tell me, why can't I have 1 for a base? Because now this is impossible. You can't put something to a power like that, 1 to a power, and turn it into 8. You get that? That's why you're not allowed to have a base of 1. So the answer to this would be undefined, because you can't have a 1 right there. Now what if it had been a more normal number, like let's say a 2? Well, then it would be 2 to the x equals 8. Do you see how that helps you to solve the problem? I can see it now. X must be what? 3, because 2 to the third would be 8. All right, there's your little review of the log for the logs section. Now let's talk about expanding. 2a. 2a, go there with me. You don't want to be working on something else. ln 8x. Do you remember that you can take, and if you want to expand something, you can rewrite it as 2 logs, ln of something and ln of something. Take a wild guess. ln of what and ln of what? ln of 8 and ln of what? X. And do I add them or do I subtract them? Do I multiply them? Do I divide them? Adding. So things that were multiplies get changed into adds. That is expanding. Remember that? All right. Next kind is log, let's do B as in banana, 2b, and it says log x y cubed. Now, if this had just been log xy, do you get, I would write log x plus log y. But there's that pesky cubed there. Do you remember where those go when you expand them? Down to the front, that's right, but down to the front of what? Just the log y, so the 3 goes there. Because the 3 was on the y. The 3 wasn't on the whole thing. The 3 was just on the y. So the 3 goes to the front of that little part. So there's your right answer for 2b. Yes? Yes, if this had been like this, then I would put the 3 down in front of the whole thing like that. All right, but it's not. You could distribute the 3 if you want to. All right, moving on. How about your ABC? 2C. Oh, I get it. For the 4th root of x over y. All right, that brings up an important point. Everybody stop for a second and just review how you write these things. Remember this? I can rewrite that as x to the what? To the 1/2. You are correct. Does that ring a bell? Square roots would be like a 1/2 power. What if this is a 3? Then it's to the 1/3. You get it? Do you remember how if I put like an 8 here, that means x to the 8/3? Notice the root's still on the bottom. And do you remember if I had 1 over x, I could write that as x to the -1? Remember that? Okay, so let's say I had, here's the hardest kind, 1 over cube root of x to the 5th. That would be x to the something, something, something. Negative is the 1 over part, yep. And then what? 5/3. And the 3's on the bottom because the root goes on the bottom. And if you think about it, if you're planting things, the root goes on the bottom. If you plant things in your garden the other way, they won't work so good. All right? All right, moving along. Let's go to a random one like F. It says, oh wait, I'm wrong. E. ln of 6th root of 4x squared. Okay, can you rewrite that as ln of 4x squared to the 1/6? Do you get that? Then if I'm supposed to expand this puppy, do you get that 1/6 will go down to the front, and I'll say 1/6 ln of 4x squared? And now if I'm supposed to expand this thing, now I can take and break up this 4x squared into 1/6 of ln of 4 plus ln of x squared. I just broke up my 4 and my x squared. And then what's the last thing I got to do to expand it all the way? That x squared has to, that 2 has to go where? Right on the front of that. Middle school move-up day or something out there. All right, moving along. Let's go look at next page. Log 20. This is problem 3A. Log 20. What shiny black thing with buttons will you have with you? It's either your calculator or maybe your phone, but you're not allowed to use your phone. So, all right. So, do you know how to put that in a calculator? Just type log 20. All right. And it'll give you a decimal, and there you go. Now, can you use a calculator on everything? Yeah, you really can. But could they change this problem to make it like Without a calculator, sure. What if they said this? Then if you were going to type it into a calculator, you couldn't, but you'd want to put what over what? Log B over log A, you are correct. All right, but this one has numbers, so you could just type in log 20 on 3A. All right, moving on. Let's look at B. That one threw me the first time I saw it. Not for very long, but we'll see how long it throws you for. First thing, it will help you a little bit if you know the base. What's the base? Base has got to be 10. So, then can you rewrite this thing? Or do you even have to? You don't even have to. It's something really simple from here. Yeah, because why? Yeah, because the base and this thing's called the argument are the same. Since those are the same, then what's the answer? 5 plus x, that's it. Now, you could go and say equals y, some other variable, and then say 10 to the y equals 10 to the 5 plus x. And then since the bases are the same, you could cancel them. And then you could say the answer, y, has got to be 5 plus x. But it'd be a lot simpler if you can just notice it. Hey, that's got to be the answer, 5 plus x. That's it. All right. Let's do condensing, 4a. Stay with me. 4a, 2 ln x plus 3 ln y. Yes, it's ln x squared. That's the first step of simplifying it, plus ln y cubed. I take the them and put them up, whereas before we were putting them down. Now we're condensing it down to make it smaller. And then what? A plus can turn into a multiply, so it's ln of x squared y cubed. There you go. Notice it used to be 2 ln's, got down to 1. That's condensing. Okay? Okay, moving on. Let's do number 5, part A. 5a, 36 parentheses 1/3 to the x over 5 equals 4. My first thought is, this is not a log at all. What's it doing in this section? Because it's an exponential. So could you rewrite it as a log? Yes, you could. As soon as you got the exponential all alone, see, this part here needs to go over to the other side, and then I'll have 1/3 to the x over 5 equals 436. And what does 436 simplify down to? 1/9, good. You're on fire today. El fuego. Right. But you know what? You're allowed to on the test, so that's all right. Okay. And now, if I take this and this, do you get that they're kind of close to each other and I might be able to make them be the same base? And if I could make them be the same base, then the bases would cancel and I'd just set the exponents equal? Do you know what I'm talking about? So if it was like this, 5 to the x equals 5 to the 4th, that you can go doink, doink, the answer is x equals 4. You want to get it like that so you can cancel those bases. All right, so let's go back here and say, how could I rewrite this 1/3 so that it would be a 1/9? Or even better, I could rewrite that 1/9 as a 1/3. If I rewrite the 1/9 as a 1/3 to the what? How do I get 1/3 to be 1/9? That's all I'm doing is taking out a 1/9, putting in a 1/3 to the squared, yeah. Now do you get that what I just replaced in blue just replaces the green thing? It's the same exact thing. Now I can cancel this and this. So now it's x over 5 has to equal 2. That has to equal that. And then I can just multiply by 2 and x must be 10. Now could you have done that a more loggy way? Yes. Let me show you how I do this exact same problem with a log. I could say log, oh, first I'm going to get this over here. I do need to do that first. Now I can make it a log. Log base 1/3 of 436 is equal to x over 5. And then with the power of the calculator, you get that. You know what I mean? You just type in the calculator. And then, how do I get x alone? I just times by 5. I times by 5 on both sides. So I take this on the calculator, and whatever it is, I times it by 5. Okay, so that works too. When you're putting these in the calculator, be sure you have parentheses around them. Otherwise, you're likely to mess them up. All right, moving along. Let's go to problem 6. It's on the next page. Number 6 says, find the radius if the arc length is 40 and theta is 20 degrees. All right, do you remember what an arc is? It's that curvy length on a circle. Okay, so if this is going to be 40, let's say it's from here to here is 40. And then this angle I just told us is 20 degrees, and the trap that you might fall into is thinking that you can use the 20 degrees. You can't. Because do you remember that the formula for this is SOR, S equals theta R technically, but I call it SOR? You remember that? You'll get nothing and like it. You have to know that. Nope, no note cards, no nothing. Just memorize S equals theta R. And if you're starting to worry about that, then make yourself a list. Pull them off to the side or something, you know what I mean? So that when you're looking through this the night before the test, you can remind yourself, S equals theta R is important. I know it's on the test. Okay, back to this. I can't use 20 degrees. I have to have radians. Another little thing, if I was making a sheet to memorize, I would have that little list of what do you multiply by things to make them into radians. It's either 180 over pi or pi over 180. And it's usually easy once you know that. Because if I go like this, I'll realize quickly, wait a minute, then no, the degrees won't cancel if I do that. So it must be the other way, pi over 180. And I know how to do that in my head quick enough so I can just say, oh, that goes, 20 goes in there once, 20 goes in there 9 times pi over 9. So I can go S equals theta R, except I know S. S is 40. It's a little bit counterintuitive, but S is the arc. I don't know why they called it S. I don't know why I don't have an A there, but they don't. And theta is pi over 9 and the radius. And now to get R alone, I just have to multiply both sides by 9 over pi, and I'll have it. All right. The next couple are the same ilk, so I don't need to do those again. Number 9, you just did that on the test yesterday. So if you don't know how to solve those, you are in deep trouble for the final, because that's like, there's a lot of that on there. I guess after saying all that, I better show you how to do it, just in case. 9a, if it's sine of theta equals 1/2, you need to know that sine can be positive 1/2 in 2 spots. All students take calc. Sine can be positive here or here. And so it must be in these 2 quadrants where I'd have my answers. And sine is 1/2, opposite over hypotenuse. Okay, and then this would be square root of 3, and then I can realize, oh, that's the 30, 60, 90 triangle. That's 30 and that's 30. My answers are not 30 and 30 though. They're 30 degrees, and the other one is 150. Now, if I wanted those in radians, I just need to know how to change them. I'd multiply by pi over 180, and I'd have them in radians. Okay? Don't really want to do B, but I'll start it for you. Tangent of theta. This is problem 9B. Tangent of theta is equal to root 3 over 3. I think it's just that you're not picturing the triangle right. Tangent is opposite over adjacent, right? So if I'm going to be here because it's positive, tangent's positive here. All students take calc. And tangent's also positive down here. I'll let you do that one later. But for this one, if tangent's opposite over adjacent, then do you have any idea, like, could this be a 45-45 triangle? If it can't be a 45-45, then it must be which one? 30-60. It's either 30-60-90 or 45-45-90. All right, so if you're not sure, then just figure out the third side, first of all. Okay, let's figure out the third side. 3 squared is 9. Square root of 3 squared is 3. Sorry, and then I'd have 9 and 3 makes 12. Square root of 12. What the heck? But then you can simplify that. What's the square root of 12 simplified to? Root 4 and root 3. And that's really 2 root 3s. And now are you starting to figure out, if this is 2 root 3 here, that this is root 3, 2 root 3s, and then a 3? Which would be like Root 3 times root 3? Which would be 3. I don't know if you're getting this. But then this is the smallest side. This is a medium size. This is the one that's twice as big as the other one. Can you tell, is this a 30-60-90 or a 45-45-90? It's a 30-60. And which angle are we at? The 30. So this is 30. And if it's 30, then the other place the tangent is positive is over here, and so you can figure out that one. Okay. All right, moving on. That was a tricky one. Number 10, the angle of elevation from the top of the Ulm Cathedral from a point 300 feet away from the base. All right, so that's like one of these deals. We got this cathedral, and let's say it looks kind of like this, and it's got the cross on the top, and at the very top of that, got my little angle here. This 30-degree angle here, and I don't know how tall the height is. I'm going to call it H, and it's 300 feet away. Remember how you set up trig for these things? Just remember the key thing here is angle of elevations always start from horizontal and then go up. So that's an angle of elevation. On the next problem, they're going to ask you about an angle of depression. And that means that they have a line like this to horizontal. Angle of depression is like this. It's going down. See, this one's going up. That's an angle of elevation. All right. And this one, to figure out H, you could do sine is opposite over hypotenuse, but I don't have the hypotenuse. I could do opposite over adjacent. That would be tangent of 30. Oh, is it? Sorry, it's 60. You're right. Thank you. Tangent is 60. Problem says 60 for that angle. Is opposite over adjacent H over 300. And then I just multiply both sides by 300. And I can use my calculator to get this part if I want. Remember, you have a calculator. No problem with using that. All right. There's a whole bunch of those kind of problems where you basically just draw triangles for situations. And that gets us all the way down to number 17. That's different. Number 17 says a radial arm saw has a circular cutting blade with a diameter of 10 inches. So it's like this. It's got teeth on the outside like this. It's got a diameter of 10. So it spins at 2,000 RPM. I encourage you to write that like this, 2,000 rot per min. Because RPM means rotations per minute. Why did I do that? Because it's one of these kind of problems. You remember I have a whole bunch of fractions going to multiply together, and you're going to finally end up, when you're all done, with something. And let's see what the problem tells me. It wants how many teeth cross the cutting surface each second. Teeth per second. Okay? I need one more piece of info. They tell me something about how many teeth there are in an inch. There are 12 cutting teeth per inch. 12 teeth per inch. Okay, so on this kind of problem, you want to get rid of these guys. You want them to cancel all the way out. So I need to do that one step at a time. How do I get rid of minutes? I put minutes up here. I was talking like Elmer Fudd to fit that down. How do I get rid of minutes? I put minutes on top. What is a fact I know about a minute? I know 1 minute has what in it? 60 seconds. And then this will cancel this. And now I've got rotations per second. It gets me a little closer. You see how I want teeth per second? So clearly I need to get rotations to cancel, so I'm going to put them down here. That way rotations will cancel. What do I know about a rotation? One rotation is equal to a circumference, right? So if I only knew the circumference of this, but I can figure out the circumference. Circumference is pi times diameter. Once you know what that is from sticking numbers in here, you'll be able to tell what the circumference is, and you put that here, and then you multiply by one last fraction. I'm not going to tell you the whole thing. At least I got it started for you. Number 18 is just like number 17. I think we could skip on to number 20. Nope. That would give you the distance. What I would do for number 17 to finish it off, after you've got your circumference here, is like I mean a certain number of inches. Then you just got to get your inches to turn into teeth somehow. So then you take inches and put it down here, and then you put teeth on the top, and you'll pretty much have it. All right, moving along to number 20. Everybody get with number 20A. I'm almost done here. Stay with me for just a few more minutes and you'll have some free time. All right. People that are reading books in the back row should be paying attention, shutting their books. Thank you. Moving on, number 20, part A. Secant x equals 2. I don't like secant. I don't know how to draw a triangle for that, but I do know how to do what one that's kind of close to it. Cosine. So instead of secant x equals 2, I'm going to say cosine x is equal to what? Since secant is 1 over cosine, it's reminding me I need to just flip it over, right? So it's going to be 1/2. You know what I just did there? I just changed my problem so that it would work nicer. In case you want to see that as like a proof, I'll show you it this way. Would you agree that secant is 1 over cosine? And then if I want to get cosine alone, I just put cosine over to the other side. 1 equals 2 cosine x, and then I get divide by 2 on both sides, and I'll have 1/2 equals cosine x. But I just like to think of it as, instead of this secant, I'm going to put cosine x, but I just can't just say of x, or of 2, I have to say of 1/2. So whichever way works for you, but either way, solve that now, and you'll have your answer. And remember, a lot of times there's 2 answers for these, because cosine is positive 1/2 in 2 different spots. Once here, and then all students take calc. Cosine's also positive down here. So you'll have 2 answers for that one. Oh. What does it say? Does it say radians? In the given interval. The interval is between 0 and pi over 2, so you are correct. I didn't read that. It only wants the answers between here and here, so I should not give them that answer. Good point. And I think the answer that they want is in radians because it says between 0 and pi over 2. So if my answer was going to be 30 degrees, I would change it to pi over 6, for instance, but it's not that, so hopefully you can figure that out. All right, moving on. Remember, on number 21, it's saying, given that sine is 3/5 and tangent is less than 0, what are they trying to say there? I'm talking about number 21. It says sine is 3/5. Think of it this way. Sine is positive then, isn't it? And then when they say tangent is less than 0, clearly they're saying that tangent is negative. So where is sine positive and tangent negative? Oh, students, take calc. Sine's positive here and here. Where is tangent negative? Well, tangent's positive here, and tangent's positive here, so I have to throw those out. So this is the spot where sine is positive, but tangent is negative. Get how I have to draw it in there? Okay, that's a problem like number 21. So it wants secant of theta. So first of all, I'd have to figure out what is sine, opposite, and hypotenuse, right? So I'd have sine is opposite, hypotenuse, and you could figure out what that is. I think it's a 4, isn't it? Make a 3, 4, 5 triangle. And then I know my 3 sides, so then if I want to do secant of it, I just first figure out what cosine of it is and then flip it. Because secant you can't do directly. Well, you can do it directly, but I don't like to. So instead of doing secant, I do cosine, and then I flip whatever cosine would have been. All right, moving on. Just a couple more. On the last page we're going to do for today is this one. Thankfully, 23 and 24 are exactly like what we just got tested on. Okay, so you should be able to handle those. I'm going to give you one hint. On B, right next to number B, write subtract tangent from both sides. Then factor. 23B, subtract tangent from both sides, then factor it. Because then you'll have this thing where you'll have tangent sine squared, and then you subtract tangent, and it equals 0. And then you can factor it, and you'll have this factored thing equals 0. And in fact, I think one of the things that factors, and you'll end up with like 3 factors and set them all equal to 0. And the very last one I want to cover is number 25. Everybody go to number 25. Do you remember what these graphs look like? I bet you don't. So I bet you should watch this. If If they asked me to graph like 2 to the x, it would look like this blue graph. That's called an exponential because it's got an x in the exponent. Do you remember the kissing cousin? The inverse of this? The log goes like this. Remember how that's a log? That's a graph of e to the x. No, I'm wrong. Ln of x, or log base e to the x. That's what logs generally look like. And the last one I'll do is in black here, an exponential decay. That's like the first one you have to do, 0.5 to the x. If I had to graph 0.5 to the x, it would start up high and then go lower and lower and lower. So the black one here is exponential decay. Why it's decay? Because that number's less than 1. All right, so there's my 3 kinds of graphs that you kind of have to know for this. And for A, I've already sketched for you what the original graph would be. But when they do this, they say if f of x is 0.5, this is 25a, if f of x equals 0.5 to the x, then what would this look like? 3 times 0.5 to the x plus 4. Do you remember that that makes and timeses it by 3, which makes the graph do what? 3 times taller. Remember that? And then what's this other dude do? Is it right 4 or is it up 4? It's up 4. Okay, so this one get 3 times taller and then move the whole, shift the whole graph up 4. And if the graph in the first place looked kind of like this, to make it 3 times taller, I take all the numbers and basically make them 3 times higher than they were. And then to move the whole thing up 4, I take it from there and move it up 4. So it's basically the same shape except moved up a fair amount. Okay, that's a lot to remember. And that's your assignment today, is 1 to 25. I will be talking about some more problems tomorrow.